13.42 involves this setup here where an object is rolling down and goes through a loop right here, and then it just clears this hill over here without just almost on the verge of coming off the ground. We're given that the radius of this loop is 20 feet and the height h that you start out with from A here with a zero velocity is 60 feet high, and we're given the weight of the person as being 160 pounds. And what we're trying to find here is the normal force that's exerted on the person at B and at D, and what this radius of curvature over here has to be such that you just on the verge of coming off the ground. To find the normal force at B and D, we're going to look at B first, and we're going to do a work energy principle. T at A plus U from A to B is equal to T at B. And we start off with a zero kinetic energy, and the only work being done on this setup is the work done by gravity, and that's going to be mgh. It's a positive work being done since the object's moving downward, and that's got to be equal to 1/2 m VB squared. We're going to look at a free body diagram at B, and when we look at that and ask ourselves the two-finger question, is there a force of gravity? And the answer is yes. The object has force of gravity acting down, and then the object is also experiencing a normal force from the seat upward. Notice the tangential direction is the direction of the velocity, and the normal direction is in this direction right here. So when we sum the forces in Newton's second law at B, sum the forces in normal equal to m times a normal, then you have nb minus w equal to m times a normal. So nb is equal to w plus m, and the normal acceleration is vb squared over r. Well, that n, then I'm going to repeat that w, and for m vb squared, well, look at mvb squared right here. It's actually equal to 2 times w times h. And then so that's 2wh, and then the r is repeated over right there. And when you solve for n sub b out of this, you get 1,120 pounds. That's about 7 g's of acceleration that's taking place there. All right, at D, the free body diagram at D would look like this. Force of gravity is acting down, and so is the normal force. The normal direction is this way, and the tangential direction is that way. You do your sum of the force in the normal again, you get n sub d plus w equal to m v sub d squared over r, and that would end up giving you n sub d then is equal to v sub d squared over r minus w. If we look at our work energy for there, starting out at A again and going from A to D, in tension and the kinetic energy at D here, we got zero kinetic energy at A. We got mg, and the distance that you have there is where you started out at h, you ended up at 2r, so your h minus 2r for the distance that's work done by gravity, and that's got to be equal to 1/2 m v sub d squared. So taking this formula right here and this formula right here to calculate n sub d, we put in that m v sub d squared from right here is equal to 2 times mg being w, so there's your 2w, and then h minus 2r, and all that divided by r from right here, and then the minus w is repeated right there. And you'll note that h is equal to 3r actually in our measurements here. So you'd have 3r minus r, this end up being just r over r, so you get 2w minus w, which is just 1w, and it's 160 pounds then, and it's about 1 g of acceleration. All right, to find the rho, what you do is that at E, the normal force should go to 0. So if you look at the free body diagram at E, all you have is the W right here. So sum of the force of normal equal to MA normal, WB equal to MA normal, and WB equal to MB sub B squared over rho. You look at your work energy principle here, the kinetic energy at A plus the work go from A to E is equal to kinetic energy at E. You start off with 0 kinetic energy at A. You're at a distance now of 2r below where you started, so the work done by gravity is mg times 2r, and then that's your kinetic energy there. You remember that W then is equal to, well, mve squared would be 2 times W times this 2r, so that'd be 4wr, and then divided by rho. And so if you solve for rho out of here, you end up the W's cancel and rho is equal to 4r, which is equal to 80 feet.